Alright, so today we are going to go through section 6.8, which is L'Hopital's rule. What a fun word, huh? L'Hopital.
How do you say it?
L'Hopital? The H is silent. It's the last name of some fancy guy who made up this rule. Yep, L'Hopital. And so the first thing we're going to look at is indeterminate form, because L'Hopital's rule is used whenever you get a limit that ends up in an indeterminate form. An indeterminate form is basically just an answer that's not defined, or an answer that doesn't exist, such as 0 over 0, or positive or negative infinity divided by positive or negative infinity. Okay, and so indeterminate form is found when finding a limit, and L'Hopital's rule is used in order to be able to continue to evaluate that limit even after the indeterminate form is found. So L'Hopital's rule says that if we have two functions f and g, and they're differentiable, and g of x doesn't equal 0, because your denominator cannot equal 0, and if the limit is indeterminate, then the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x. So you can take your derivatives and find the limit of your derivatives, that it will give you your answer. Okay, so if I look at example 1, I'm asked to find the limit as x approaches 1 of the natural log of x divided by x minus 1. Okay, so the first thing I have to do is I have to determine if this is indeterminate form. If it's not, then I'll just evaluate it by direct substitution. So I'm going to plug in the 1 in for x in the top and the bottom. So I end up with the natural log of 1 divided by 1 minus 1. Which I get the natural log of 1 is 0, 1 minus 1 is 0. So I end up with 0 over 0, which is one of our indeterminate forms, because you can't divide by 0. So we're going to use L'Hopital's rule. So if I let f of x be the natural log of x, and g of x be x minus 1, then what's f prime of x? What's my derivative of the natural log of x? Anybody remember what the derivative of natural log is? 1 over x. Natural log of x is 1 over x. And what's my derivative of x minus 1? 1. Okay, so L'Hopital's rule says that I can evaluate that same limit as x approaches 1 of f prime of x, so 1 over x, divided by g prime of x, which is 1. And if I simplify this, 1 over x divided by 1 is just 1 over x. So this becomes the limit as x approaches 1 of 1 over x. And so if I plug in that 1 in for direct substitution, then I get 1 over 1, which is 1. So my limit is 1. Okay, so let's do the same thing for example 2. I'm asked to find the limit as x approaches infinity of e to the x divided by x squared. Okay, so if I plug in infinity in for my x's, I get e to the infinity divided by infinity squared. E to the infinity is just infinity. Infinity squared is infinity. So I get my indeterminate form, infinity over infinity. So I'm going to let f of x be e to the x. G of x be x squared. Which makes f prime of x. What's my derivative of e to the x?
Yeah.
Yep, e to the x. And if I find g prime of x, what's my derivative of x squared? 2x. So I'm going to find the limit as x approaches infinity of e to the x divided by 2x. So if I plug in infinity for both of those, I get e to the infinity divided by 2 times infinity. Or we just said e to the infinity is equal to infinity, just like on the first one. 2 times infinity is also equal to infinity. So I get another indeterminate form. So let's find our double derivative then. So if I want to find my second derivative, f double prime of x is equal to, what's my e to the x, because e to the x just always stays e to the x. And what's my derivative of 2 to the x? 2. So if I rewrite my limit again, I get the limit as x approaches infinity. My double derivative, my second derivative is e to the x. My second derivative for g of x is 2. And then if I continue to plug in infinity for my x's, I get e to the infinity divided by 2. And that becomes infinity divided by 2, which is in fact just infinity. That is good. We can stop there. We couldn't stop here because you can't divide by infinity. But we can stop here because you can in fact divide by 2. So let's do one more like that. So that was example 3. I'm asked to find the limit as x approaches infinity of the natural log of infinity divided by the cube root of x. Okay, so if I plug in infinity for each of these, I get the natural log of infinity divided by the cube root of infinity. Natural log of infinity is just infinity. Cube root of infinity is a slightly smaller infinity. So I get infinity divided by infinity. So I have indeterminate form. So I'm going to let f of x be the natural log of x, and g of x be the cube root of x. Okay, so if I want to find f prime of x, what did we say the derivative of natural log is? 1 over x. And if I want to find the derivative of the cube root of x, I can rewrite this as x to the 1/3 exponent, because then it's easier to derive. So this would become 1/3 x to the negative 2/3. So then if I want to find my limit as x approaches infinity of f prime of x, which is 1 over x, divided by g prime of x, which is 1/3 x to the negative 2/3. Well, let's start by simplifying. We become 1 over x times 3 over 1x to the 2/3. If I move my x to the top to make it positive and flip this fraction, I get 1 over x times 3 over 1 x to the 2/3. If I multiply then straight across, I get 3 x to the 2/3 divided by x. And then if I simplify this x to the 2/3 divided by x, it's like x to the 1, 2/3 minus 1 is negative 1/3. So this becomes 3 over the cube root of x. Okay, so if I plug in infinity into my equation, I get 3 divided by the cube root of infinity. And what did we say the cube root of infinity is? Infinity, and what's 3 divided by infinity? A small number divided by a big number would approach 0. Yes, when you're dividing by infinity, you get 0. So my limit would equal 0. It's a terrible square. Okay, so L'Hopital's rule, pretty straightforward. You just find your derivatives and derive. So 447, 1 through 3, 7 through 18.